All right, welcome, welcome. We are on day 6 of our quadratics unit. It certainly seems like it's been more than 6 days, but we are on day 6. We are going to be picking up here on page 27. So let's go ahead and make sure we got our packets out. And let me see if I can find this. Why isn't this working? This is a great start. All right. There we are, page 27. Awesome. So, solving quadratic equations like 3x squared minus 15 equals 0 and 3x squared minus 15x equals 0 locates x-intercepts on the graphs of the quadratic functions. Okay, so here are the graphs of each one. Where do we see those solutions represented on the graphs? So if we're talking about the specific graph of 3x squared minus 15x. We're talking about this one here. And we're looking for the solution to this equation. Where do we find the solutions to this equation on this graph? That's the question that part B is basically asking. And so we know that we're looking for when the function equals 0. And so we're looking for right there. And make sure I'm on the right one, right here. And so we see that it's at x equals 0 and x equals 5. That's a 5. It's a little bit better. And then in general, right, in general, it's where the graph crosses the x-axis. Okay, so to find those x-intercepts, or the roots, or the zeros, we have several names for them. This first step is going to be very important, right? Because we have to find when the quadratic is equal to 0. So we have to set it equal to 0. And then we solve, right? And we have all these different methods of solving. We've factoring, which we did kind of last unit a lot, and then we did more of it this unit. We have the quadratic formula, which we've gone over a lot. And then we have, from the last unit, we have the completing the square method as well, right? So we have all these different methods to solve. That's what it's used for, to find these solutions. And then the solutions we get are the x-intercepts, okay? Part C, based on the graphs above, so looking back up here, based on those graphs, how is the location of the minimum or maximum related to the location of the x-intercepts of a quadratic? So if I am looking at, again, let's take a look at this when we were just looking at before. So if I'm just looking at this one, and I have the x-intercepts, where in relation to these two x-intercepts is the minimum of this graph? So this kind of goes back to that idea that a quadratic function, a parabola, the graph of one, is symmetric. And so the minimum or maximum, or in other words, the vertex, is right in the middle, right between the two x-intercepts. Is, let's just say that, right between the two x-intercepts. Right, directly in the middle, okay? So, for example, if my two x-intercepts were, 2 and 8, well, then I would have to figure out what number is directly between 2 and 8 to figure out where the vertex would be. And so that number would be 5, because 5 is directly between 2 and 8. So that's where the vertex would be. It's not the coordinates of the vertex, it's only the x value of the vertex. And with that idea of symmetry, I think we're going to talk about the axis of symmetry. So an axis of symmetry would be just like that sort of line that you can draw on a graph, which breaks the graph into two halves that are like exactly the same, right? Symmetric. That's the axis of symmetry. And so it goes right through the vertex. So here are, again, a refresher on how we find that vertex. There's a couple different methods we could use. First, we could use the idea we just talked about and say, okay, well, you could find the roots, right? The solutions, the x-intercepts, right? So you could find the x-intercepts. And then you can find directly in the middle, right? Halfway between the roots. And then that's the x value for your minimum or maximum. Then to find the y value, you would just plug that x value into the rule, and you would find your y value, right? And that's your coordinates of the minimum and maximum. How do you determine if it's a maximum or a minimum? Well, it's based on what the graph looks like, right? So if it's a maximum, if the graph opens downward, right? If it opens down. It's a minimum, right? Because this point would be now a maximum. It's a minimum if the graph opens like that, upward. Okay? Or we can use this axis of symmetry. So axis of symmetry comes from this formula. X equals negative b over 2a. And that's just a quick formula to find that axis of symmetry, the x value of the vertex. So you could use that. It'll just quickly get you the x value, and then you would plug the x value in to find the vertex. So for example, if we're looking at this one, the 3x squared minus 15, we have to identify a, b, and c, right? So a is 1, b is 0, because there's no x term in the middle there. And then c would be negative 15. And then using this formula, we would just plug in our b, right? And we'd plug in our a. And so we'd see that the x value for the vertex is 0. Now, taking that 0, plugging it back into this function, we get negative 15. And so we know that it's 0, negative 15. We also know that it's a maximum because this graph opens up. So no, this would be a minimum. Sorry about that. Not a maximum. It's a minimum. So there would be a minimum at 0, negative 15, right? Okay. So let's take a look at how to do this. I'll maybe use a couple different methods here, or primarily I like to factor because I think it's one of the skills that we really have to master here, and so that's why I like to use that as often as I can. So for part A, when I find the roots, I'm probably going to factor. If it's not factorable, that's when I'm going to use a different method. And then we're going to find the coordinates of the vertex as well. So to find the roots, remember that first step is always to make sure we're finding when the function's equal to 0. So I'm going to set it equal to 0. So x squared plus 4x equals 0. Now I am going to go ahead and factor this because it is factorable. I can factor an x out of both of these. Now I can set each factor equals 0. And so this one's done, right? X is already by itself. This one I just have to subtract 4 from both sides to get that x by itself. So there's part A, right? My roots, my x-intercepts are x equals 0 and x equals negative 4. Okay, so the coordinates of the vertex, well, now I can use this idea where I'm going to look right between these two, right? What's right between 0 and -4? Well, that would be -2. So I'm going to plug -2 into the function. And evaluate it. So that's going to give me 4 minus 8. And so I'm going to have a y value of, let me split this so we know what we're doing here. This is part A. This is part B. We're going to have a y value of -4. And so the vertex is going to be at -2, -4. Okay? And the a value, right, the coefficient in front is positive, which means this is going to be a regular U-shaped parabola, right? This is going to look like this, which makes it a minimum. Okay? Next example. Let's break that up. Okay. Part A for the next example. Again, I'm going to find the roots of the quadratic, so I'll set it equal to 0. And I can factor this again. I can factor an x out. And set both factors equal to 0. This one's solved for me, right? This one's done. This one I have to do a couple steps. I have to subtract the 10. And then I have to divide by 3. And I get -10/3. Okay. So I have my two x-intercepts. If I want to know now what the vertex is, well, what's right between 0 and -10/3? That might be a little more difficult to figure out what's directly between the two. So what else can we do? We can use this, right? -b/2a. So if I'm going to use this, -b/2a. Well, my a value is 3, and my b value is 10. So x equals -10/2 times 3. And so the x value is -10/6. Okay, which reduces to -5/3, which can then be plugged into the function to evaluate this and figure out what the y value is. So I'll go ahead and do that now. So I would have 3 times -5/3 squared. That's a 5/3. And plus 10 times -5/3. And here we can go to our calculator and sort of just plug this in, figure out what we get. So we would have, let me go back to the main screen, 3 times -5/3. And that's going to be squared plus 10 and -5/3. And we get -8.3 repeating, so let's go ahead and turn that into a fraction. So I pressed math. Remember, math, enter, enter turns things into fractions. So math, enter, enter, -25/3. So, where's my pen? -25/3 was the y value. So the coordinates of my vertex, you guys can still see this, right? Yeah. The coordinates of my vertex, here's the x value, here's the y value. So the coordinates would be -5/3, comma, -25/3 for part B. All right? So the next page we would go through, I would encourage you to pause this video, work through this page, try to do this on your own first, and then unpause, and I will finish that up. Okay. The next page as well looks like it's more practice, right? So let's go ahead and work on these next two pages, page 29 and page 30. Okay. So I'll be doing them one at a time. So if you want to like do one, unpause, see how you did, and keep going like that, I think that would be a great idea. Okay? So I'm going to find the x-intercepts and y-intercepts of the quadratic. I'm going to find the coordinates of the vertex. I'm going to identify whether it opens up or down. And then I'm going to kind of graph the function without the calculator based on what I found out and draw the axis of symmetry. Okay. So let's start with a little list here. X-intercepts, I'm just going to put sort of my answers in one little area. I'm going to have my y-intercepts, I'm going to have my vertex, and I can figure out all the rest. Okay. X squared minus 4x plus 4 equals 0. I'm going to find the x-intercepts. I'm going to factor this. This is a sum product. Are there numbers that multiply to 4 and add to make -4? Yes, this would factor into x minus 2 and x minus 2. Okay, and so we solve this, we get x equals 2. And x equals 2, right? But it's only one solution there. X equals 2. So my x-intercept is x equals 2. The y-intercept is 4. Okay, the coordinates of the vertex. Well, remember we said the coordinates of the vertex would be when we'd be right in the middle of the two x-intercepts. If there's only one x-intercept, right, or it happens twice, it's x equals 2 and x equals 2, what's right between 2 and 2? Well, it's just 2, right? So we want to figure out what the y value is, so we're going to plug 2 in. And that's going to give me, let's see, 4 minus 8 plus 4, and that's going to give me 0. So 2, 0 is the vertex. What's the a value of this? The a value here in front is a +1, so it's positive, so it's opening upward. Or I can just kind of sketch what it should look like, right? All right. And now I have enough to kind of sketch this graph. I'll put the y-intercept, or the x-intercept of 2 right there, which means I've also graphed the vertex because it happens to be the same point. I'm going to graph the y-intercept of 4 right there. I'm going to go ahead and use symmetry to kind of get another point here, right? Because if this is the vertex, then this point is symmetric. So I'm going to go across to where this would be on the other side, right? And I'm going to get a little parabola that looks something like this. And I'm going to have my axis of symmetry here. Ooh, that was pretty bad. Let me see if I can do that a little bit better. Nope. Axis of symmetry goes right through the vertex. The axis of symmetry is when x equals 2. Okay? And there we go. That's question 1. Let's take a look at 2. So let's see, x squared minus 6x plus 5 equals 0. Can we factor this? Are there numbers that multiply to 5 and add to make negative 6? I believe negative 5 and negative 1 would work. Okay, so that means using the idea of factored form and solution form, x equals positive 5 and x equals positive 1. Those are my x-intercepts. Y-intercept. What's my y-intercept? Well, let's look at the standard form. My y-intercept is 5. Does this open upward or downward? A value is positive, so this is going to look like that. Right? It's going to open up. I already forgot what I was supposed to do. Vertex, obviously. So can we figure out what's right between 1 and 5? Yes, we could use this idea of right between, because I think this would be one of the ones that we could kind of figure out, right? I believe 3 is right between 5 and 1. So I'm going to plug 3 into the function. And let's see what we get here. What is that? 18 plus 5. And so we get negative 4, I think, I hope. Looks about right. So our vertex is going to be at 3, negative 4. Okay, so now we have enough information to start plotting this graph. So let's start with the vertex. 1, 2, 3, negative 4. Put the vertex right there. The x-intercepts are at 5. And 1. Got a y-intercept at 5. And now I can graph this, okay? I can use this idea of symmetry again to put one more point on this. So where would that point go? Well, actually, let me show you. Here's the axis of symmetry, right? If I could do that correctly, that would be the axis of symmetry at x equals 3. And so by using symmetry, if I'm here and I'm 3 x values away from the line axis of symmetry, then I have to be 3 x values away from the line of symmetry on this side. Right? That's how we just use symmetry to fill in points. And now I have enough to go ahead and try and make a parabola. And there we go. All right. How'd you guys do? Hopefully well. Remember, if you have questions on this stuff, drop into our office hours, okay? Next page, we are going to find the x and y intercepts, find the equation of the axis of symmetry, find the coordinates of the vertex, and up or down. So same stuff, we're just not really graphing it anymore, okay? So again, I would ask you guys to pause and try it yourself and then check how you did, because I'll just go through and work through these now, okay? So I'm going to see if I can factor this, and I could factor a negative 3 out first, which would give me negative 6x plus 8 Now I can check, can I factor this further? Are there numbers that multiply to 8 and add to negative 6? Yes, that would be negative 4 and negative 2. Okay, so now we want to identify the intercepts. I probably should have started with that 0 there. So x equals 4 and x equals 2 are my x-intercepts. Y-intercept is negative 24. I'm going to write that as a coordinate point just so I know it's the y-intercept, so I don't have to keep writing y-intercept all over. You know. Vertex of the quadratic, let's see, right in the middle of these would be 3. So let's plug 3 into this quadratic. And let's see what we get when we simplify. Let's look, negative 27 plus 54 minus 24, 30, and show 3, I think, hopefully. So our vertex, I guess I do have to identify what I'm talking about here. My vertex is at 3, 3. And this was my y-intercept. And those are my x-intercepts. We know that. And the a value in this case is negative 3. And so this one's going to open downward. I'm just going to put that here because of that's how I'm figuring it out, right? That one opens down. Number 2. X squared minus 4x minus 5. There we go. And let's factor this. This would factor into negative 5 and positive 1. So I get x equals 5 and x equals negative 1 as my x-intercepts. So what is right between 5 and negative 1? So probably should have talked about this before as well. If you're kind of wondering, well, how do you figure out what's right between something? Right between something is technically the average of the two. So you just add them together and divide by 2. So if I add 5 and negative 1 together, I get a 4, right? Because 5 plus negative 1 is 4. I divide that by 2, I get 2. So 2 is right between 5 and negative 1. So I'm going to plug 2 into the function. And I have a hard time writing 5s, I guess. I don't know what's going on here. There we go. And let's see what we get here. Negative 4 was at negative 9. So my vertex is at 2 comma negative 9. Those are my x-intercepts. My y-intercept is negative 5. And the a value here is positive, so this is opening up. Okay. Next. 5x squared plus 11x plus 2. This is a great factor in review, by the way. So this one we are going to have to use the AC method, or factor by grouping, however you call them. So 5 times 2 is 10, so I'm looking for numbers that multiply to 10 and add to 11. So that would be 10 and 1. So split that 11x into 10x plus 1x. Now this is where we kind of split it down the middle, factor both sides. This factors into 5x plus 1 times x plus 2. And so we get x equals negative 1/5 and x equals negative 2. And to figure out what's right between those, I could certainly just add them together and figure out what's right between them. Or I could do this negative b over 2a, which I'm going to go ahead and do that because it seems easier to me. So negative b over 2a gives me negative 11 tenths. Negative 11 tenths. So that'll be fun to plug in. We will put negative 11 tenths in to this function. And evaluate it. So I'm going to turn to my calculator here and plug that in. 5 times 11 tenths squared plus 11 times negative 11 tenths plus 2. Negative 4.05. Okay. I do think I remember something about rounding here, so let's check that out. Negative 4.05, and the x value was negative 11 tenths is negative 1.1. Let's see what we were supposed to round to. Well, technically it was only on the x-intercepts and y-intercepts. So sure, we can keep it this. I would keep it this. This is exact. No need to round that. Negative 1.1 to comma negative 4.05 is the vertex. And the a value is positive, so this opens up. And the y-intercept is 2. So the y-intercept is at 0, 2. Okay? How are we doing on time? Number 4. Another factor by grouping, I believe. 6x squared plus x minus 2. So that's going to be negative 12 when I multiply them. So I'm looking for numbers that multiply negative 12 and add to make a positive 1. So that would be 4 and negative 3. So 6x squared plus 4x minus 3x minus 2. I'm going to split that down the middle. Factor both sides. It's going to be 2x on the outside, x plus 2. What am I doing here? Sorry. 3x plus 2. And then I'm going to factor minus 1 out. 3x plus 2. So I got 2x minus 1. 3x plus 2. Set both those factors equal to 0 and solve. And we get x equals 1/2. And we get x equals negative 2/3. Sorry, yeah, I was just thinking I probably should have gone back here and written that as a x equals negative 0.2. right, because I just remembered for x-intercepts and y-intercepts, it did say to round to the nearest tenths place. So let's put these as decimals. X equals 0.5 and x equals negative point, to round to the nearest tenths, we would say negative 0.7. I don't really like that. I don't really like rounding to the nearest tenths here. I would prefer to just leave it as the fraction, okay? But because it does say to do that, I'll do it. All right, vertex negative b over 2a gives me negative 1/12, and then plugging negative 1/12 into the function, I'm going to save some time here and just kind of plug it in. So negative 1/12, 6 parentheses, negative 1/12 plus negative 1/12 and minus 2. Or is it plus 2? That's minus 2. Okay, and we get negative 2.583333333333 and negative 31/12. Okay, so negative 1/12, negative 31/12 is my vertex. And does this open up or down? This opens up because the a value is positive. And what's the y-intercept? 0, negative 2. So based on all that work, you can kind of see how we were figuring out all these different features. And so just to summarize that, how do we identify the values for A, B, and C? Well, for that, we need to be in standard form. So standard form, which is y equals ax squared plus bx plus c, right? And then we can just kind of look and see what's a, what's b, what's c. How do we find the y-intercepts? Y-intercept, again, standard form, it's the c value, right? That's kind of what I was doing on all of those problems. How do you find the x-intercepts? We're going to set the equation equal to 0 and solve, which means factoring, quadratic formula, completing the square, okay, any way to find the x-intercepts. How do we find the axis of symmetry? It's going to be negative b over 2a. Then, nope, that's just the axis of symmetry is right there. Okay, if we were doing the vertex, then we would plug it in and find the y value as well. How do we find the maximum or minimum? So plug, this would be the next part of that, plug in the x value of the axis of symmetry. Or calculator. I like that method, right? Go to the left, go to the right. find the minimum and maximum. That works too. So that is, I believe, it for day 6. So hope you're all doing well. That's it for me. I will see you on the next awesome episode of Algebra Class. See you guys.